we have now learnt what to do when you have one block on an incline. But what happens if there are two blocks and one of them is on the incline and is connected by a rope? Then what happens? Actually nothing much. What is this force? 60, remember? Just simply resolve. In fact, I am not even now writing the mg. What is mg? 60. mg sine theta. So 60 into sine 30. So 60 sine 30 degrees, which is how much? 60 into half, 30 newtons. This is 60 cos 30. I won't write it because I don't need it. I can simplify if I want, but I don't need it. There is an n. I don't need it. Why? Because these are all things that are going to be in the perpendicular direction. I only care about this direction. Okay? Now let us see. There is a T. That means there is a force like this which is equal to T because the tension is the same on both sides of the rope. There is a force T on this object. There is a force T on that. But the direction, it's a pulling force, so it's going to be like that. Right? Now this force is 30. This force is T. You know that this fellow is going to accelerate down like that. This acceleration is A. This acceleration is A. Now, if this becomes too fast, the rope will have a slack. If it becomes too slow and this becomes fast, the rope will break. So obviously, the rope neither breaks nor has a slack. That means this and that must move together. Okay, so this is A, that is A. Now let us take this case. Now if I write this equation, 6 into A, you see that direction, it is 0, no? Acceleration is 0. I don't care about it. Why? Because nobody's asked me. They have asked me to find T and A. T and A. Nobody's asked us to find N. If I want to find N, what will happen? Then I need to know that that acceleration is 0. Then I will calculate this. But nobody's asked us that. Okay. So right now, 6 into A, mass into acceleration in this direction. What should I write here? 30 minus T. Not T minus 30. 30 minus T because the acceleration is pointing that way. So 30 minus T. Don't stop here. Write the equation for this. For this, 2 into A must be, there's only one force, so T. There is no friction, frictionless, smooth surfaces. Okay, so that means I've got this far. If I add this up, T will cancel. 30 is equal to 8A. So what is A? 30 by 8. 15 by 4. Now you can calculate what 15 by 4 is. Basically 16 by 4 will be 4. So 15 by 4 will be 3.75 meters per second square. Now is this I cap or J cap? Here is a trick. For this it is I cap. For this it's not I cap, it is this direction. So we are only going to talk about A in terms of its magnitude. A I cap, 3.75 I cap. 3.75 down the incline, not I cap, because I cap will mean that direction. Okay, so that is clear. Now, but I want to find T, no? T is the second part of the question. We found A, but you know this is A, substitute 2 into 15 by 4. How much is that? 15 by 2, 7.5 newtons. So this is 7.5 newtons. Does it make sense? 7.5 divided by 2 is 3.75. So that is correct. So this is correct. Now let us see. This is 7.5. 30 minus 7.5. How much is that? 30 minus 8 would have been 22. So 30 minus 7.5 will be 22.5. So 22.5 divided by 6. Okay. If you calculate, you will find that will also be 3.75 because you can calculate divide by 3, you will find that it will be some 7.5 divided by 2, 3.75. So you can see that this gives you the answer for the acceleration for this and for that. That is why tension has to be 7.5 newtons. What have we done? We have now taken this mg sine theta and are now using it with two blocks connected by a rope. Let us think about one more case where we might have to use something like this. So in this question, I have two blocks that are connected and basically one of them is on the incline and it's basically connected by a massless rope and massless pulley, etc. to another block which is on that side. Now you can see clearly that even if they were both kept vertically, this is going to pull it down. You know that this acceleration is going to be A downwards, and this fellow will also have an acceleration along the incline like that. Now this force, gravitational force, is easy. This is going to be 100 newtons, mg. This tension T is the same on both sides, so this force is going to be T. This force is going to be T along the incline. Now you look at this force. What is this force? 50, right? Mg is 50. So mg, I want sine theta, but mg is going to be 50, 5 into 10, into sine 37. Sine 37 is 3 by 5. And so therefore you're going to get 30. So instead of writing 50 and then doing the resolution, I will write mg sine theta, this is 30 newtons. There is also an mg cos theta this way, mg cos theta, and there is an n. I'm not bothering writing all this in detail because you know it's only going to move this way, so therefore I'll only focus on that. Now this fellow is going to go up that way, so let us start by writing Newton's laws. 5a, mass into acceleration. Now it is in this direction, t minus 30. T minus 30. Now if the acceleration was like this, then I would have written 30 minus t, but now the acceleration is like that. So I'm writing t minus 30. When you come to this side, 10a downwards, right? It is not t minus 100, it is 100 minus t. 100 minus t. So if I now just add this, you can see that the t cancels out, giving us 70 is equal to 15a. And so a is 70 by 15. Dividing by 5, we'll get 3 in the denominator. Dividing by 5, this is going to be 14. So 14 by 3 meters per second square, that is the acceleration. And how do I find out what is the tension T? Substitute this acceleration into one of the two equations. So let me substitute it here. So T is equal to 30 plus 5 times A. So 5 into 14 by 3. Now this is 14 into 5 is going to be 70. So 30 into 3 is 90. 90 plus 70 by 3, which is how much? This is going to become 160 by 3 newtons. Okay, so we have found both tension T, which is 160 by 3 newtons, and we have found acceleration 14 by 3 meters per second square. Main point, this fellow's mg, you are resolving it into mg sin theta, mg cos theta. After that, this problem looks like the other problem you have already learnt. Remember this problem? Okay, so if for example, I have a 5 kg block and I have a 10 kg block, I would have done 100 newtons and I have done 50 newtons. Correct? This is 50, that is 100. And then I would have done T, etc. Except now instead of this 50, just imagine that this has now been tilted. Instead of mg downwards, you now are going to say mg sin theta along this rope. That's all. That's the only difference. So later I will tell you how you can use a shortcut to just look at this question and directly write the answer. But that we will do a little later. Right now let us focus on basic approach because this is something that is useful in many cases. Okay. So mg sin theta. Just write mg sin theta, mg cos theta. Focus on the mg sin theta. You write the F equals ma for this, F equals ma for that. The best way to learn these things is to do a lot of problems. So let us do a few practice problems. We'll do that also. Okay. Now, once you have understood this, this is a reasonably straightforward idea. You will get used to the idea that you can take mg, resolve it and mark it as mg sin theta, mg cos theta. Many problems in many exams come from just this simple idea. Now keep in mind all this works for a fixed inclined plane, fixed wedge. Sometimes people call this a wedge. It is a fixed wedge, which means this incline is not moving. But in some rare cases, when you push, this incline may be moving. If this incline starts to move, then things get a little bit more complicated. So then you will have to understand what to do, but that is not something that we will look at right now. So you should know how to solve these type of problems Main idea, resolve mg, then use Newton's laws. Okay, is that clear?